Here we have the chaotic oscillator function with input the current state y and the carrying capacity parameter z, and with output the next state f of y and z. Let's take a closer look. Its definition says that, if y is less than z, the output should be the growth multiplier times y. Otherwise it gets rescaled, reversed, and mapped back toward the lower value states. Here it is again in its entirety. To explore, we will use iterate the function f of y and z, where the parameter z is set to 8. Call that function f8. Rz is set to 8. Call that function f8. If we start at state 1 and apply f8 to it, we get 1.25 as the next state. Apply f8 to it, we get 1.25 as the next state. When we apply f8 to that state, get 1.5625, then 1.953125, and so on, each state being 10/8 of the previous until the state value crosses 8. At which point the population crashes, and the state jumps down below 8 to start growing again. To check the growth factor, we will take a state, copy it, apply f8 to one copy, and then divide the new version by the old. Result at 1.25 or 10/8 as assumed. What happens if we land on the carrying capacity exactly? The state jumps back to 6.4, which then is multiplied by 1.25 to get 8 again. A cycle. What happens to a state very slightly below 8? It goes almost to 10, and so will jump close to 0 after that. From there it will continue to grow and grow exponentially, as it is said. And a state just barely above 8? It goes to a state just below 6.4 and spirals out from there. In the next node, we will look at how the dynamics plays out over time. That is, dynamically.